Hey guys, hey, welcome back. Welcome back to your latest installment of Learning Algebra with Mr. Bauman from Mr. Bauman's basement. So, change the position of the camera, change the position of my chair. I'm in a new spot, new background, new lesson for you. So we're going to get right into it. We're continuing to move forward in Chapter 9. We're getting, you smell that? It smells like the end of the chapter. We're getting so close. We're at 9.5 today. Honestly, we only have one more section to cover. I'm going to skip one section towards the end, but the last section we're going to do in the next video is the quadratic formula. Very exciting. We've kind of been building up to this formula. But before we get there, we're going to cover 9.5 today, called Completing the Square. Once we finish Chapter 9, towards the end of April, 1st of May, we're going to jump into Chapter 10, do 2 or 3 sections from Chapter 10, hopefully get to 2 or 3 sections in Chapter 11, which is exactly where I get to every single year. So guaranteed you guys are going to be ready to rock and roll with algebra next year in the fall. So miss seeing you guys, miss you a lot. I wish you were in the classroom, but we're making the best of the cards that we've been dealt. So we're ready to go. I got my whiteboard, got the magical eraser, I got my marker, and of course, no algebra lesson is complete without some good old hot coffee. And today it's pretty hot. So good. Alright, so we're going to jump into it. You need your notebook, need a pencil. Definitely going to need a calculator today. So if you need to pause the video, go get those 3 things. We're going to jump right into it. 9.5. We're going to be solving a quadratic. So kind of the first part of the objective stays the same. We're still solving quadratics today, but we're going to learn a new method, not factoring. That's what you did in the last video. We're going to solve a quadratic by what we call completing the square. Completing the square. So in your notebook, again, if at any point I'm going a little bit too fast, just pause the video. Pause the video and catch up with the notes. What I'd like to do is take just a few moments here to kind of recap all the methods that we've learned so far. We've been hard at work here doing these videos, you watching these videos, working on some Google Docs. I hope at this point, kind of my goal for Chapter 9 was to get you to a point where you could solve any quadratic in a number of different ways. First one we looked at before spring break, you learned how to solve a quadratic by graphing it. And essentially, by graphing it, you were finding the x-intercepts. The x-intercepts are the solutions. And we talked about advantages and disadvantages of graphing. Probably the biggest disadvantage is that it takes some time. A big advantage is that it kind of gives you a kind of a picture, a graphical model of sorts of what this parabola, what this quadratic really looks like. Second method we looked at was using square roots. If the quadratic is in this form, ax squared plus c, in other words, it doesn't have a b term, it doesn't have a middle term, then finding the square roots is probably your fastest way of doing it. That was the second method we looked at. The third method we looked at was factoring. That's the one we just did in the previous video. If I give you a quadratic and you're able to factor it, factoring was I think, really pretty straightforward. Once you had it factored, we used what we called the zero product property. It allowed you to find those usually two solutions, sometimes one, sometimes none, but it allowed you to find the solutions rather quickly. That's what you just worked on in the last video. Today, we're going to be learning a fourth method for solving a quadratic called completing the square. It's most often used is if the quadratic looks like this. Ax squared plus bx equals 0. Notice now there's no constant. There's no last term. There's no c term over here. That's the form that we generally use completing the square for. So that's kind of a recap of the last, probably 3 or 4 videos. And I need some space here on my board. And we're going to jump into what exactly does completing the square look like. So we said it's typically used when you have a quadratic in this form. Ax squared plus bx is equal to 0. Now, you kind of have to take a walk down memory lane here. back to chapter 8, we talked about what's called a perfect square trinomial. It's been a while. It's been probably close to 2 months since we've looked at this. A perfect square trinomial. A perfect square trinomial had 3 terms over here. Right now we only have 2. So it's a trinomial. So we're trying to get this to be 3 terms instead of 2. Whose first term and whose last term are perfect squares. We don't have the third term. So my question is, how can I turn this binomial into a trinomial that is a perfect square trinomial? You might want to star this next statement because it's an important one. So this quadratic can be converted into a perfect square trinomial by adding b over 2 squared to both sides. Big statement here. Definitely want to star this, highlight this in your notes somehow. It's an important one. So this binomial can be converted into a perfect square trinomial by adding b over 2 squared to both sides. Again, if I'm going a little fast, pause the video so you can get this in your notes. Definitely highlight this. Most certainly, every one of you watching this video is going to see this next year. Whether you're in Algebra 1 or you're in Algebra 2, guaranteed you're going to be doing this next year. Converting this binomial into a perfect square trinomial. Here's the key right here. b over 2 squared, that number is going to be added to both sides of this. So let's put this into practice. Let's actually use some numbers here, not just some general statements. Let's try this out on a quadratic. So we're going to look at, we'll call this example 1. Let's do x squared plus 20x plus c. X squared plus 20x plus c. My question is, what value of c would make this a perfect square trinomial? Move this camera down a bit. There we go. What value of c would make this a perfect square trinomial? It all comes back to that, I just drew on myself. It all comes back to that statement that we just had in your notes. The key is b over 2 squared. So the question is, what's b? What's the value of b? We know that the number in front of x squared is always a. That's the leading coefficient. We've done that a lot in the past. So a is 1. b is the coefficient of this middle term, right in front of the x, not the x squared, but in front of the x. This is the value of b. It's 20. So let's go ahead and evaluate this expression here. b over 2 squared, that'd be 20 over 2 quantity squared. Using the order of operations, you have PEMDAS. Please excuse my dear Aunt Sally, you have to do the parentheses first. So 20 over 2, that's right, that's 10. So this is really 10 squared. So the value of c that would make this a perfect square trinomial is 100. So if I plug that value back in, this new quadratic up here, x squared plus 20x plus 100, this is now a perfect square trinomial. Why? Well, it's obviously a trinomial because now we have 1, 2, 3 terms. And it's a perfect square trinomial because of this reason. This is a perfect square. We can take the square root of this and get x. This is a perfect square because the square root of 100, that's right, is 10. If you multiply this root, x, times this root, 10, and double it, you get this middle term. That's from a couple months ago. Let me repeat that. If I take the square root of this, I get x. Take the square root of this, I get 10. Now multiply those together. 10, see if I can write backwards here. Square root of this one times the square root of this one, doubled, is the middle term, which by definition makes this a perfect square trinomial. You might be wondering, okay, I get that, I remember that, but what does that have to do with completing the square? This new method today that we're learning. That's a great question. So how can we turn a perfect square trinomial into something that can be solved? So, new example, call this example 2. Now we're finally starting to solve these. So now the directions are going to morph into what we kind of looked at last couple of sections. The direction's simply going to say, what are the solutions? By the way, the example that we just did, like 2 minutes ago, that's very similar to the first question on your homework on the Google Doc. What we're getting ready to do now, it's like most of the rest of the problems. It's actually asking what are the solutions of the quadratic. What are the solutions of the quadratic? If you need to pause the video, go ahead and do so. Get these directions down. I'm going to go ahead and write the quadratic. So we're going to try to solve x squared minus 14x squared minus 14x plus 16 equals 0. Alright, so you have some options here. Could you graph it? Yes, you could. It would take some time, but if the graph would be a right side up parabola, it would look like a bowl because the leading coefficient is positive, and we would be trying to find where does it cross the x-axis. Those two x-intercepts are the solutions, but graphing takes time. Next year you're going to have a graphing calculator which will allow you to graph those much faster, but that's next year. Could you factor it? Probably, but we did that last section. Let's focus on completing the square. I know a lot of you are list writers, and I got to try to squeeze this onto this little whiteboard, but I'm going to try my best here. I think for completing the square, writing this list of steps is really going to be helpful, whether you're a list writer or not. This is a list that you can refer back to in your notes, especially next year. I would strongly suggest you hold on to this year's notes to use next year in 9th grade. I'm not going to see you in person in our classroom to remind you of that. Please hold on to your notes. I've had a lot of former students use their 8th grade notes in high school to help refresh them on what these topics are. So these list of steps I think will be beneficial. Step 1, subtract C from both sides. I'm going to write a little bit smaller here, try to fit all these steps in. Subtract C from both sides. Why? Remember at the very beginning of this video, initially we only had 2 terms over here. I have this third term here. So let's take this term over here. Let's take this constant, which is our value of C, let's take it over here to the right side. So let's subtract C from both sides, and we end up with x squared minus 14x equals negative 16. That's step 1. Will you have to do that every time? No. In fact, we're going to look at an example here in a few minutes where you don't have to do that. But if there is a c, take it over to the other side. All right, step 2. We're going to add, and here's the key step. You might want to star this, circle it, highlight it if you have a highlighter. We're going to add b over 2 squared to both sides. What are we forming when we do that? That's right. We formed, and I'm going to abbreviate it, we formed a perfect square trinomial. Step 2, add b over 2 squared to both sides, forming a perfect square trinomial. That's the key step. Please underline, circle, do something to show that step 2 is really, really crucial. All right, so let's do that. You got to do a little calculations here. B over 2 squared. What's our value of b? B again is always in front of the x, not x squared, in front of the x. So our value of b is negative 14 over 2 squared. Negative 14 over 2 squared. You got to do the parentheses first. What's negative 14 over 2? That's right, it's negative 7. Anything squared, except 0, anything squared is always going to give you something positive. So when we square negative 7, we actually get positive 49. Negative 7 squared is positive 49. That's what I'm going to add to both sides. So back over here in my workspace, I'm going to add 49 over here, add 49 over there. I have to do it to both sides because of what we talked about in 7th grade, that whole teeter-totter effect. You can't teeter without tottering. You got to add the same thing to both sides. So I'm going to get x squared minus 14x plus 49 equals, what would that be, 33. X squared minus 14x plus 49 equals 33. I'm not done yet, but I've completed the first 2 steps, and I think the longer 2 steps. All right, I got to create a little space here. Give me a second. All right, step 3. Step 3, factor the perfect square trinomial. So essentially what you've created over here, this is a trinomial, and guess what? It's a perfect square trinomial. Why? Well, there's obviously 3 terms. Is this a perfect square? You betcha. Is this a perfect square? You betcha. If you take the root of each of these, the root of this one is x, the root of this one, the square root of this one is 7. Multiply them together, that's 7x. Double them, you get this middle term. So let's factor this. This is where last chapter's skills really come into play. Last chapter's lessons, last chapter's skills really come into play. To factor a perfect square trinomial, take the square root of this, that's the first term. The square root of this is the second term. The symbol that you have here, just bring it straight down. This is negative 7. So it's the quantity x minus 7 squared. Could you have written it like this? X minus 7 times x minus 7. equals 33. Yes, you could have written it like this, but let's write it like this, and I'm going to explain why here in just a second. Okay, so it could have been written like this, but because we're multiplying the same binomial together, let's just square it. Okay, let me again create some space here. So that's step 3. And now we're really, really close. We're really close. Keep in mind, I'm trying to find the solutions. I'm trying to figure out what's the value of x, right? So I need to start undoing things over here so that x is by itself. I got to undo this square first. How do you undo square? Don't say circle. You undo square by square rooting. So the fourth step is you're going to square root both sides. Square root both sides. Alright, so let's do that. Square root the left side, square root the right side. What happens to square and square root? That's right, they cancel each other out. So I end up with x minus 7 equals radical 33. Radical 33. Is this a perfect square? No, this is not a perfect square. That's why you needed your calculator. We're going to approximate this here in just a second. Do I have x by itself? No, but it's close. What's the only thing you have to undo? That's right. You just got to undo this minus 7. How do we undo minus 7? That's like basic 7th grade pre-algebra. You just add 7 to both sides. So we get x is equal to 7. Now keep in mind, here's a little reminder from a previous chapter. How many roots technically are there here? That's right, there's 2. This is actually plus or minus radical 33. So this is your 2 solutions. One of them is going to use the plus sign. One of them is going to use the minus sign. So there's technically 2 solutions here. If I had graphed this, my parabola would have crossed 2 times. But we're not going to graph. Also, some good knowledge for next year. These 2 solutions, these are your 2 exact solutions. Why are they exact? Because I haven't picked up my calculator yet. I haven't figured out yet what the square root of 33 is. So these are my 2 exact solutions. The problem is, most people don't know exactly about what these numbers are. So that's why we need a calculator to approximate these. Alright, so go ahead and pick up your calculator. And let's approximate these two solutions. So I've already done my calculations earlier. So I use this symbol. So it's no longer equal. It's approximately equal to. It's PDC. It's pretty darn close to what 2 numbers? So this is 7 plus or minus, and I rounded to the nearest hundredth. So this is 7 plus or minus 5.74. So x is about 12.74 and x is about 1.26. I didn't bring my calculator down here, but I'm trying to read my own handwriting from when I worked these out. These are your 2 approximate solutions. These are your 2 exact solutions. The moment you pick up your calculator and type this in, you get something that is irrational. These decimals, I rounded it, but this decimal technically keeps on going forever. It doesn't repeat. I don't think it repeated. Definitely doesn't terminate, which makes it irrational. So I get about 12.74 and about 1.26. These are my two approximate solutions. This is what I'm looking for on your Google Doc. When I ask you to solve this using completing the square, I want the approximate solutions, and I think again I ask you to round to the nearest hundredth. And of course you could check it. You could take these two numbers, put them back into the original quadratic, and you would get approximately equal numbers. Approximate because we rounded. Alright, I promise you that every time you do this after the one that we just did, it'll take less and less time. The first time doing anything always takes the longest, whether it's riding your bike, tying your shoe, whatever. It takes a while to get used to, but know that these will take less and less time the more you practice it. And that's what we're going to do right now. Let's practice another one. So let's call this example 3. And again, if at any point you have questions, please make sure you shoot me an email. Let's try g squared, word up g, plus 8g equals 180. G squared plus 8g equals 180. I'm going to move a little bit faster through this one. You can refer to the steps that we wrote in the previous example, steps 1, 2, 3, 4. You have it in your notes. I don't have it on here anymore, and I'm not going to rewrite them, but refer to those 4 steps as we move through this example. All right, g squared plus 8g equals 180. All right, here we go. We don't need to subtract c from both sides. This is what I was talking about a few minutes ago. There is no c, so we can't subtract c if it's not there. Technically it's 0, so step 1 we really don't have to do in this one, which is kind of nice. So we're going to move right on to step 2. We're going to add b over 2 squared to both sides. So you gotta have to do the work off to the side here, just on the margin of your notebook. Go ahead and calculate this. Half of b, and then square it. You should be able to do that in your head, honestly. b is 8, so take 8 divided by 2, that's 4, and then square 4, that is 16. So let's add 16 to both sides. So we get g squared plus 8g plus 16 equals 196. So this should be the next line in your notes. How can we classify this trinomial? That's right, it's a perfect square trinomial. Why? Take the square root of this, that's g. Take the square root of this, that's 4. Multiply them together, that's 4g, and double it, it's the middle term. So we could say this is a perfect square trinomial. Alright, so next steps, which is step 3, factor this trinomial. Again, it's a quantity squared. It's a quantity squared. The first term is just the root of this. The second term is the root of this. So this is g plus 4. Alright, we're already on step 4. Look how much quicker we're working through this. We're already in step 4. Let's start undoing this left side so that g is by itself. How are we going to undo square? That's right, square root. Let me get some space here. Alright, let's square root both sides. If you square root over here, you got to square root over here. Square root both sides, they cancel, so we get g plus 4 equals the square root of 96. which happens to be, I believe, again, I don't have my calculator down here, but I think it's a perfect square. Let's keep it as a radical here just for a second. And again, technically, there's two roots. It's plus or minus radical 196. How are we going to undo this? That's right, subtract 4 from both sides. Subtract 4 from both sides. And we get G equals plus or minus radical 196 minus 4. I went ahead and switched the order just to show you, just to kind of prove to you that I can put the radical first and this constant second, or I can flip-flop them. I can put the radical second and this number first. It doesn't matter. Just make sure you don't put this minus 4 underneath the radical symbol. The only thing that's underneath the radical symbol is the 196. But I could have just as easily flip-flopped the order of these two terms. But this radical, again, has two radicals, which tells me that there's going to be two solutions. Again, 196, I believe, hope this is right, I believe 196 is 14, their square root. So G is equal to plus 14 minus 4, or negative 14 minus 4. Again, you have to use both of these symbols, the plus and the minus. So the first solution is positive 14 minus 4. The second solution is using the negative 14 minus 4. So our two solutions happen to be exact. We didn't need a calculator on this one. Our two solutions, G is equal to 10 and G is equal to negative 18. 14 minus 4 is 10. Negative 14 minus 4 is negative 18. Perfect. So if we had graphed the parabola, or if this was next year and you had a graphing calculator, what could you say about the graph? That's right, it would cross at negative 18 and positive 10. The two intercepts would have been these two numbers. Alright, let's try one more and then we'll put the finishing touches on this section. Again, I think it's good to get some practice. I'm trying to keep these videos down in length, but I'm trying to teach a whole lesson. In fact, most of these videos are 2 lessons. Had we been in the classroom, most of these would have taken 2 days to do. I'm trying to speed up the process because I'm trying to get you to a point where you're going to be ready for 9th grade algebra. And we're going to get there. It's just not the traditional way of getting there, but we're going to get there. In the words of Troy Bolton, we're all in this together. We're making the best of what we can do and what we got, and I get a really strong feeling you guys are learning what you're supposed to learn. It's just in an unorthodox way. Same directions. What are the solutions? Let's look at x squared plus 9x plus 15 equals 0. Again, you could graph it, you could factor it, but we're going to use completing the square, CTS. Let's solve this using completing the square. Alright, here we go. Step 1. Flip back in your notes if you need to. Step 1 was what? That's right, take C over here. So if there's a C over here, move it over there. So I'm going to subtract 15 from both sides. So your quadratic now looks like this. I changed the look of it, but I didn't change the value. It kind of goes back to the wedding cake that we looked at way back in the fall. This equation and this equation are exactly the same. They look different, but they have the same value because I subtracted 15 from both sides. Alright, step 2. Let's add This is where you kind of do some calculations off to the side. We're going to take b over 2 and square it. Probably going to need your calculator on this one because we get some the func factor is pretty high. We're going to get some decimals here. So what's the value of b? That's right, b is 9. Divide it by 2. That's 4.5. Now we have to square that. Take 4.5 squared, and I believe that is 20.25. 20.25. That's what I'm going to add to both sides. So if I add that to both sides, this is where a calculator comes in handy. I get, trying to clear some space here, x squared plus 9x plus 20.25. Now when I add 20.25 to this right side, I got to add it to negative 15. So take negative 15 plus 20.25 and you end up with 5.25. So here's my new equation. What can I call this trinomial? That's right, it's a perfect square trinomial for the reason we've already talked about. This is a perfect square, this is a perfect square. Take the root of each, double it, you get this middle term. All right, we're almost there. Let's factor this. Again, we know it's going to be a binomial squared. The first term is the square root of this, which obviously is x. The second term is the square root of this one. Now you can certainly use your calculator. Take the square root of 20.25. I'll give you a chance to do that. What'd you get? You should have gotten the same thing that we had at the bottom of this board here. You should have gotten 4.5. Because that's how we got 20.25, was squaring this. So the square root has to kind of circle back around to where you started. All right, let's start undoing this. What do you undo first? That's right, undo the square first. But you got to do it on both sides. Square and square root cancel. Square root of 5.25, that's about 2.29. But again, there's two of them. One's plus, one's minus. So this is plus or minus 2.29. I just rounded to the nearest hundredth. All right, now the last thing we have to do is get rid of this plus 4.5. So subtract 4.5. So my approximate solutions, there's two of them. Again, that's what I'm looking for tonight. If they're not exact, give me the approximates. Rounded to the nearest hundredth. So the first one's going to be positive 2.29 minus 4.5. That's going to be my first one. The second one's going to be negative 2.29 minus 4.5. First one's using the plus sign, the next one's using this minus sign. Go ahead and take out your calculator. The first one has to be negative, and it looks like that's about negative 2.21. And the second one's about negative 6.79. There you go. This is what I'm looking for on your Google Doc tonight. Rounded to the nearest hundredth. Most of them are going to have two. I think there might be one, I can't remember. There might be one problem that only has one solution. I don't think I gave you any that have 0 solutions. But there are my approximate two solutions. If I had graphed it, those would have been the x-intercepts. Perfect. We're going to end with a story problem. Didn't think you're going to sneak out of here without a story problem. I'm going to start this one for you, and then you're going to see one very similar to this on tonight's assignment. So, last one. I'll at least get you started here. Let's suppose you had a picture, and we're trying to figure out the dimensions of this picture. So let's suppose the width is x, and the length is x plus 4. So you had a rectangular picture whose width is x and whose length is x plus 4. Let's also suppose I gave you the area of this rectangle. Let's suppose, and these are all, let's just call them inches. Let's suppose the area was 32 square inches. My question is, what's the value of x? Well, if you know its area of a rectangle, you have to use length times width. I mean, that's just like bare bones, like younger grade school days. This is the formula for the area of a rectangle, length times width. Do we know the length? Kind of. It's just not a number. Do we know the width? Kind of. It's just not a number. So let's plug in the length and the width into this formula. Let's also plug in what we know about A. What do we know about A? That's right, it's 32. So area is 32. My length is the quantity x plus 4, and the width is x. So I plugged in area, length, width. Hopefully you recognize now, we can now use the distributive property here. There's a factor on the outside, two or more terms here on the inside. So let's distribute this x. So 32 equals x squared plus 4x. And oh my gosh, we got a quadratic, right? We've got a quadratic that I think completing the square would be really quite appropriate for this particular quadratic. Why? Because C has already been taken to the other side, so let's try to complete the square. I'm going to do one more step on this, and I'm going to have you complete this one very similar to this tonight. So my quadratic looks like this. I flip-flop the two sides. X squared plus 4x is equal to 32. I just flip-flop these two sides. First step's already been done for you. Let's add b over 2 squared to both sides. We should be able to do that in our head. b is 4, so 4 over 2, that's 2. Now square it, that's 4. So I'm going to add 4 to both sides. Factor this. What's going to go here? That's right, it's x. I love this problem so much. I'm just going to complete it for you real fast. This is x. What goes here? That's right, it's the square root of this one. So that's plus 2. We're almost there. Square root both sides. Square and square root cancel, so we get x plus 2 equals, we know the square root of 36, that's plus or minus, there's two roots, plus or minus 6. Now just take away 2 from both sides. So my two solutions, x equals positive 6 minus 2 or negative 6 minus 2. X equals, I'm trying to read backwards here, positive 6 minus 2 or negative 6 minus 2. Again, I had to use both of these symbols, the plus and the minus, because this has two roots. But keep in mind, I'm looking at dimensions on a picture. I can't use this one because it gives me a negative number. You can't have a picture that has a width of -8. So this one just doesn't make any sense. I'm just going to erase that one. It's got to be this one. +6 minus 2, that's 4. So the value of x was +4, which means the length of the picture, I didn't ask for that, but it had to have been 8 because I said the length was x plus 4. And you could check it. Oh my gosh, what's 8 times 4? What's the area of this picture? It's 32. So you're going to see one very similar to that on your homework tonight. I know this is a longer video, but again, this is 2 days worth of material crammed into one video. So I really appreciate you guys watching this. I hope you found it helpful. You now know 4 different ways to solve a quadratic. We're going to be looking at the last method in the next video. Everyone's favorite, the quadratic formula. It's very exciting. Your parents studied it, your grandparents studied it. They've been studying for hundreds and thousands of years. So that's going to be in the next video. Appreciate you watching this. You can go ahead and open up your Google Doc. Be kind to one another. Be patient with one another, and above all, don't forget to pray. We'll see you guys. We'll see you guys in the next video. Have a great day.